Welcome to our second video about probability distributions. In this one we'll introduce the binomial distribution. But actually we saw it already in the previous video when we considered 4 throws of a fair coin. We worked out these probabilities and then we counted them. For example, the number of ways to get 3 heads. Well, there were 4 different ways to get 3 heads, each of which had probability 1/16. And we can work out these probabilities. I'll show you later on how the calculator does this with a function called the probability distribution function. But let's do the new things. Now we're making it more general. We have 4 throws, that's our number of trials, and this time the probability of success, i.e. throwing ahead, is P. It could be anything. And tails is Q. Of course P plus Q must equal 1 because they're complementary, mutually exclusive events. When you throw a coin, you either get head or tail. That's it. And as we did before, we can count how many ways to get 3 heads, for example. There's one way. And there are a total of 4 ways. If we follow the tree this way, for example, 1 tail, then head, 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 has a probability P cubed Q. And there are 4 like that in total. And then we just go through the tree, counting the number of ways that each event can happen. Here we have tails, head, tails, head. That's a total of 2 heads with probability Q squared, P squared, and there's 6 ways that can happen. So we carry on through the tree. And then a convenient way to write that is in the form of a table. A table is a nice way to show a probability distribution. Now, again, we have the binomial coefficients 1, 4, 6, 4, 1 from the Pascal's triangle. So there's definitely a link with the binomial expansion. Do you remember if we did P plus Q to the power 4, one way to write that is 4. Oops. Like this. In other words, this is what we call the general form of the binomial expansion, and that gives us a function which describes in a general way everything that's going on in that table. This is called a probability distribution function, which is shortened to PDF. Now let's just talk about some language for a moment. The number of heads is distributed binomially with parameters 4 and P. That describes the experiment. We're throwing a coin 4 times. The probability we get what we're looking for each time, what we're counting, is P. That's the probability of a head. And that's sometimes written like this for short. It's a lot easier to write. And this sign stands for is distributed. and the B stands for binomially. Your calculator understands that as binomial PDF, and the syntax goes like this. That's the trials, that's the probability of success, i.e. the thing we're trying to count, and this is the event. So this one here I could get by typing binomial PDF 4 1/2 3, because I want to know the probability of 3 heads. And if you try that on your calculator, you'll get those numbers. Okay. A bit of a summary. In general, we don't throw 4 coins. It might be some other device, some other experiment, but they all have n independent trials. So we're counting from a finite number of independent trials. And in each trial, there is success or failure. So if we're counting the number of heads, success is defined as you throw a head. And that's a constant probability of P. And here's the formula that we've talked about. A situation which follows this structure follows a binomial distribution with parameters n and p. And we see them there in the formula n and p. Okay, let's do an example. A fair coin is tossed 10 times. Calculate the probability of obtaining exactly 3 heads, at least 4 heads. Now the procedure here, which is useful, is you write down the variable, the random variable, which is the number of heads. The distribution is distributed binomially. The parameters are 10 and 1/2. It's only 1/2 because we're told it's a fair coin. Okay, and then the event for A is the probability, the number of heads is 3. Well, with the formula, I hope we're still recording. Let's just assume we are. We could see that that will be 10, 3, 1/2 to the power 3, 1/2 to the power 7. And now we can revise the binomial coefficient. That's 10 factorial over 3 factorial, 7 factorial. And that simplifies to 1 over 2 to the power 10. Do some cancelling. You will end up with 15 over 128. I'll leave that as an exercise for you. 15 over 128. Let's do the other one. At least 4 heads. Now that's a different event. It means this, at least 4 heads. Now that means the number of heads could be 4 or 5 or 6 or 7 or 8 or 9 or 10. We don't want to add all those up. That's a lot of work. We can use this trick, but that means we have to work out the probability x equals 0 or 1 or 2 or 3 and add them up. We can do that, it just takes a lot of time. Thankfully, there is a shortcut. We can just type into the calculator this. Now, CDF stands for cumulative distribution function. Cumulative, remember that means you add up. And what that does is it does this. It adds all these up automatically. It saves you a lot of time. So this is definitely one for the calculator paper. So when you type that in the calculator, like here, gives you the answer. And this one is the one we did earlier, which is 15 out of 128. You can also give it a beginning and an end. Like this one means the probability x is between 10 and 4. That's the same as saying 1 minus the probability x is less than or equal to 3. If you look at these two answers, they're the same. We're pretty much done. Today's photo, well, what's this? Another bunch of skew lines? No, this is where I was on Friday night. My phone's a bit antiquated, so I couldn't see the famous people I was in the company with through the phone. But here they are, thanks to YouTube. This is where I was on Friday night. Brilliant!